Okay, this is Michael from Blue Sky Bio. I'd like to welcome everybody who's joining us for tonight's webinar presentation. This presentation is part of the 2017 webinar series that started at the beginning of 2017. We probably had around 15 presentations so far, and we're continuing the lineup with fantastic speakers and presenters. A couple of technical things before we get started. Please make sure to enter your details into the webinar attendance form. There's a link for the form next to the video box. And if you have any questions during the presentation, you can enter them into the chat box, and we'll probably leave some time at the end for Dr. Scherer to answer the questions that arise during the presentation. Tonight, we have the pleasure of hearing from Dr. Michael Scherer. I think we could summarize his background and capabilities just by saying he's a digital dentistry guru. Really, everything connected to dentistry, digital, is his specialty. He's involved in lecturing, teaching, he's running his own digital courses, and tonight we have the pleasure of hearing him present on the topic of avoiding rookie mistakes during guided surgery and implant placement. So I'd like to introduce Dr. Scherer.
Well, great. Thank you, Michael. And it's a pleasure to be able to be here for this webinar for both you and for Blue Sky Bio and for everybody tuning in. I'd like to, again, welcome everybody to this webinar. And it's kind of a presentation of a summation of what I've experienced both with myself and with my students at UNLV and a variety of other places on the private side in regards to how we approach guided surgery and some of the things along the way that I've kind of picked up. And I know that we all kind of tend to look at this and we say, what's the best way to get started? What are methods that we can use to go ahead and avoid those rookie mistakes? So I sincerely hope you all enjoyed this presentation. If you have any questions, feel free enter in the comment section and we'll address those. Just a quick little background about me. I am a full-time clinician in Northern California, a small town, only about 4,500 people or so in my town. And while we draw from a slightly larger area than that, what's interesting is that even in my small town, there's almost 6, potentially 7 dentists now who have a cone beam machine. The power of digital imaging in dentistry, as well as especially implant dentistry, is becoming so commonplace these days that it is beyond inspiring. Also, I do have a few affiliations with these institutions you see in front of you. And if anybody has any clinical questions that I don't have a chance to answer during this presentation, feel free and email me at the email link below. Certainly goes without saying thank you and acknowledging Blue Sky Bio for putting on this webinar. And I encourage you to check out their product portfolio, their implants, their software. What everybody is accomplishing at Blue Sky Bio is transcendent, especially considering that you've got basically a free software and a very, very reasonably priced implants. The level of support structure as well as the quality of the implants are truly remarkable. Some quick disclosure statements. Anything that I'm presenting on here tonight is not an endorsement of the institutions I'm associated with. And I am disclosing that I'm a registered speaker for Zest Dental Solutions. And again, even though contrary to some, I do not have any financial relationships with Formlabs. And again, just a quick disclosure, many of the techniques that you see in this presentation here is not an endorsement of Blue Sky Bio. It is my clinical techniques of what I use in my clinical practice. There are additional online resources available for this presentation. Certainly the Blue Sky Bio Academy and the Facebook group is inspiring to log on and to work with dentists all over this world. To see what we can accomplish when we collaborate is just truly inspiring. I encourage everybody, if you've never been on there, if you're tuning into this webinar, go check it out. The intelligence of the group and people that are on there with the individuals contributing with their techniques is amazing. Certainly have my personal website with my publications, YouTube channels. I'm up to 5 now, and a blog. Feel free to check those out. And then, of course, like Michael was mentioning before, I do have some additional online resources available and in-person courses available out here in California and at the Hinman Dental meeting in Atlanta. Just as a promotion for everybody tuning in, if you type in the coupon code BSB webinar, it will give you $100 off the online course for the first 100 people who do so. What's interesting too is I just literally got back today from being able to share some of these things that I've been doing with digital dentistry with people that are not dentists. It was kind of a professional honor to be able to present at MIT on digital dentistry. And what was really cool is that the introduction to the entire presentation was the CEO of this company, and three of the main examples, and the one that he started with was dentistry. And 3D printing and dentistry we're at just the beginning of it. And many of you that are associated with Blue Sky Bio, and especially the Academy website, are the true pioneers. I encourage you, check out things of guided surgery and then also the things beyond it. It is remarkable what's happening out there in the engineering world. So the general gist of tonight is we want to talk about guided surgery, and especially the things of guided surgery that will help us in avoiding mistakes. Mistakes are oftentimes poor outcomes. However, we have to understand that mistakes can and do happen, and that's not necessarily going to result in a poor outcome if you know how to manage it. Ultimately, we're trying to avoid this. Now, this is classically a civil engineering example, but what we know is that the combination of the restorative plan and the surgical plan should never do this. And I certainly title this inadequate guidance. Some advantages of using guided surgery, especially for those that might be new to it tuning into this webinar, we certainly know that guided surgery helps us avoid in some of the critical anatomy, sinus, nerve structures, vascular structures, bony contours, etc. It ultimately gives us restorative and surgical control at the same time. And it was kind of the central tenet of some of the things that we were talking about over the past several months, which is guided surgery is not specifically just surgery. It's also guided prosthetics, to borrow a term from a friend of mine, Daniel Lopp. Daniel Lopp coined this term of guided prosthetics. Guided prosthetics is simply using a surgical guide to enhance our restorative outcomes. And if we think of it that way, it's merely just the guide providing us the guide for all of the things associated with it. However, the ultimate end goal is to improve the quality of our restorations. Part of that also is involved is the paralleling and timing of the implants, meaning the spin of the implants. Certainly, it goes without saying that if used properly, guided surgery can make tasks faster or more efficient with your workflows. While not initially, because initially things can be relatively complex. Once you get your hands on this and you start using more of these materials and techniques over time, it goes without saying that guided surgery tends to make you a much more efficient clinician. Some pretty principal disadvantages of guided surgery, however, is the historical cost nature associated with it. Now, I call this historical because Blue Sky Bio and the team of Blue Sky Bio and everybody on the user groups and the Facebook forums are contributing to the methodology of decreasing the cost of these surgical guides. And while I got started with guided surgery in 2005 or so, the surgical guides back then were proprietary. They were extremely expensive, thousands of dollars, and extremely cumbersome and limited. Over the course of the past few years, and part of that genesis came about from an homage and the reduction of surgical guides and other laboratories participating. We're finding that the reduction of surgical guide costs is a significant improvement in being able to provide improved delivery of patient care. And with the addition of 3D printing in a clinical practice, it brings it down to, tens of dollars instead of hundreds of dollars. Now, that being said, cost is certainly a decrease over the years. There is still a historic complexity associated with surgical guides that we'll help to address here as the presentation goes on. And then it really goes without saying that one thing that we tend to overlook as clinicians is the limited opening of our patients and how much our patient can open and close. More to come on this later on in the presentation. Now, finally, one thing sometimes that we don't necessarily always recognize is that if we're drilling an implant down inside of a bony structure, we have to provide the proper irrigation to that osteotomy while we're drilling. Now, the research does show that an overheating of bone can contribute to necrosis of the bone and potential failure of the implant. That is certainly up for debate. These tend to be the three big main reasons of why we would use guided surgery in our clinical practices. Now, you may say, well, no, in my practice, it's all about safety to ensure safety around the nerves. Or, hey, I want to have multiple implant guides so I can do an all-in-4, all-in-5 case, multiple unit case, overdenture case, 3-unit bridge case. I want to have the precision like you see here on the right-hand side of the screen. But ultimately, what I found over my time is that guided surgery makes things much more predictable for me. While safety and precision are certainly part of the equation, what I'm also looking for is that predictability in my clinical practice is ultimately going to increase the efficiency of care, and predictability for me is really tantamount to success in a clinical practice. Predictability of guided surgery for being able to perform the procedure at a certain speed, and then also predictability of knowing that guided surgery is going to operate and function in a similar way helps me to contribute to proper implant placement. Now, it goes without saying that this tends to be a contentious debate in the world of guided surgery. What is accuracy? What are we looking for in implant placement, and especially the purposes of a surgical guide? And it helps for us to go ahead and further describe what is accuracy. Many times we think of accuracy as being this. We're taking darts and we're trying to hit a dartboard, and we want to hit the center. Totally understand. But it helps for us to define the differences between accuracy, precision, and then a combination of the two. Precision is taking those darts and hitting them in the same position on the dartboard, but not necessarily in the center. Accuracy is throwing the darts, hitting the dartboard all in the center or nailing the target, but not necessarily in a tight distribution. Or there could be some, deviation between where those positions are. Now, ultimately, what we're trying to do in implant dentistry and all of clinical dentistry is finding a fine line between precision and accuracy. We want to go ahead and kind of nail both of these. Now, is that achievable with what we can do in implant dentistry? We certainly hope so. One thing that we do have to talk about, though, is the literature. What does the literature show us in terms of what a surgical guide can reasonably accomplish for what we're trying to do clinically? And I show you this information because this is kind of a broad overview of what some of the literature shows. The literature shows that on average, accuracy increases with more support of your surgical guide. Meaning, if you look at a whole host of different papers, and clearly you can find some papers that show otherwise, but when you look at the entirety of the research and what's available out there, there's a general trend that tooth-supported is more accurate than bone-supported, and mucosa-supported is kind of bringing up the rear. Now, this is also somewhat glaring because you look at this and you say, well, even according to the literature, the most accurate guide of what we see here, I'm seeing mean deviation angular differences of 2.26 degrees, coronal positional errors of a mean of 1 millimeter, and apically 1.15, where on the mucosa supported side, a mean potential error rate of 1.65 millimeters. Now, I'm always nervous and cautious when a person comes up to me and says, well, yeah, this might be true, but there's this new and latest greatest thing that makes this all null and mute. Well, yes and no. What we have to understand is that technological innovation can certainly help this, but there are some underlying factors of guided surgery that we have to know and understand to help avoid the clinical errors of what we can find. And keep in mind, doctors, that I am a huge, massive fan of guided surgery. The most important thing that I love to be able to talk about with clinicians, especially at courses and just over a beer at a meeting, is to talk about, yes, we have to understand this information, not for the fact of we're trying to scare someone. No, what we want to do is we want to leverage what we know about this information so that way we can build this into the equation and make our surgery better. If we can compensate for some of this, that will ultimately give us a better clinical outcome. Interestingly enough, one of my co-residents, a good friend of mine, Nate Farley, he presented also here with this webinar series. Incredible person, just absolutely brilliant. And he designed this study looking at a split mouth, looking at guided surgery versus freehand surgical approaches. And what they found also in that clinical study is that when you take a split mouth study, yes, there is a consistent variability that is potentially possible across the board. And what we know is that while that might be true, computer-guided surgery does have some significant accuracy improvements in certain dimensions. And one thing that we have to look at this is that where are the little things along the way that is contributing to some of these angulation differences, some of these apical coronal positioning differences, and that's the gist of what we're going to be talking about tonight. Certainly, on top of that, some additional research is showing that meta-analysis shows that bone-supported guides can also provide a lower accuracy than that of tooth or mucosa-supported guides. If you do enough of these types of surgical guides, you know that there's a variability of how a software package or a human being can render a three-dimensional object from individual photons or from a CBCT scan. And what's interesting about that is that there's a lot of interest in being able to make this better. But what the moral of the story is a lot of the research is showing is that it's somewhat challenging to go ahead and use bone-supported guides, and they're really principally recommended in case with advanced bone resorption. Now let's also talk about this. Guided surgery is incredibly precise and predictable. However, we have to understand that guided surgery can be incredibly accurate, but the research also shows that there's some areas that we have to look at. And the reason why we're talking about this is that these are little things that we do in our clinical practices, whether we know it or not, that can contribute to our clinical outcomes and ultimately give us a better experience of surgical guide use. In many ways, yeah, I get it. We're tuning into a webinar to talk about what are some of the tips and tricks to avoid those rookie mistakes. Oh yeah, I'm going to cover that. We're going to get right into that. But what's also important is we have to kind of talk about the elephant in the room, which is we also have to look at some of our clinical protocols of the things of where we may or may not necessarily see potential for error to occur. And it really starts with the CBCT scan. How many of us know that we should fairly regularly calibrate our CBCT scanner? Yeah, not many of us. It's some things that we don't necessarily talk about, and we don't necessarily assume that my CBCT scanner is working properly all the time. Now, this can vary in terms of how your CBCT scanner company operates their calibration process, but calibration is very important for these machines. Then you also have things like voxel size settings, patient movement, and then certainly positioning within the CBCT scanner. The literature and also testing validation studies show that the closer that you get to the center of the CBCT scan array, the more accurate your scan is. After the CBCT scan, we have to go ahead and come up with some sort of intraoral representation of our patient to cause an image fusion to be able to generate a surgical guide if you're going to do a tooth or mucosa supported guide. The intraoral representation is certainly a point where we can have some changes, and that is stone model accuracy, impression accuracy. If you are using an optical scanner for your models, whether it's a CBCT scanner, again, calibration, or a desktop scanner at the laboratory, or potentially using other types of scanners. Certainly, if you are utilizing an intraoral scanner in your practice, cross-art stitching, and depending upon which type of optical scanner you use, is it powder versus powder-free? Is it a scanner that is reliable in cross-art stitching, meaning you reach the midline, and then as you cross the midline, is it going to be repeatable as you cross the midline, and is the trueness going to be something that I can rely upon? Then in addition to that, you have the planning software. Now, Blue Sky Planning, is one of the finest planning softwares on the market right now. But remember, there's still a human attached to the software, meaning us. The interpretation and how we manage how the mandible, maxilla, and other tooth structures and the thresholding controls, meaning the slider controls of how much data that you bring in, is certainly a part of it. Then the X factor, incorrect planning, and then certainly merging the optical scan. On top of that, you have some of the manufacturing side, printing versus milling. Do you have to calibrate your 3D printer? Do you need like a DLP printer, which you have to calibrate on a fairly regular basis? Or do you use an FDM printer or a laser SLA printer, which those tend to need a little bit less calibration? Certainly is up for debate. Post-processing, one thing that is kind of the dirty little secret of 3D printing, and I heard it here at the MIT presentation this past week, is that the dirty little secret in 3D printing is post-processing. There's a lot of variability in post-processing and how you clean the models, how you clean the guides, how you cure them, how you work with them, how you polish them, separating from the build plate, separating from the platforms, etc. And then certainly without saying how you place your guide tubes. Are you placing them at an angle, etc.? Your guide design, mucosa, bone, tooth support, fitting of the guide, certainly undercuts and blocking out of the undercuts, path of placement, anchor pin placement, how you're placing them, and then certainly guide sleeve tolerance. And then finally, when the guide goes to the mouth, are you using a block versus local? If you use a block technique, which is generally what I recommend, versus a local, if you're going to go ahead and touch up the tissue, maybe the patient's feeling a little bit, you're going to get tissue swelling. As the tissue swells, that could cause the guide to fit incorrectly. Tissue resiliency. If you have a patient like a mucosa-supported guide and there's a lot of flabby tissue existing across the arch, that can clearly affect how your guide fits. Now, there are techniques to help go ahead and alleviate that. We'll cover that. And then pressure and angulation during osteotomy preparation, leaning on it. If you're right-handed like me, we tend to lean one direction versus somebody that might be left-handed. And then finally, overheating during the actual osteotomy preparation. Now let's kind of go into some of the nuts and the bolts here. What I find with these giant lists is that I like to break it down and say, where do I find across from my experience and working with others, what are kind of the top 3 things of where I think we can go ahead and focus our attention to help avoid some of these rookie mistakes. Now, number 1, across the board, generalized human error. Now you think, come on, Mike, this is kind of just a cop-out. You say there's a broad brush, what human error is. No, the little things, the absolute little things, like I'm going to make an impression and alginate, pour it up, but I forget to go ahead and separate it before leaving for the day. I come back in, it's locked around the model, and I break off a cusp. Oh, you know what? I'm going to take a little bit of super glue, pop it on there, and I'll work around it. Or maybe, forgetting that we're also an analog human being when we fit the guide. Maybe it's a mucosa-supported guide. We want to go ahead and fit the guide and make sure that it fits just like a complete denture. Generalized human error can be incorporated at any point through the process. And what's interesting too is that the more that you know about digital technology, the more that we kind of want to trust it. And it's true, digital technology works extremely well. Unfortunately, and this is not a snide thing as I say this, but unfortunately, we humans want to go ahead and find a way to quote unquote make it better, which sometimes screws it up. Now, what's funny is that this was just talked about in some of the robotics meetings, and what they're finding is that robotic surgery is an incredibly accurate way of doing surgery. And while that is still on the horizon in dentistry, I'm still kind of skeptical myself. I really love the ability of you to use intraoral surgical guides and the flexibility associated with that. Number 2, mechanical error within the guide. What does this mean? Well, the mechanics of how a drill fits through a metal sleeve or a metal tube, or potentially a resin tube or zirconia sleeve, that can be a significant factor. The length of the drill, the angulation that you put upon it, the tolerance of how the drill fits the cylinder is a significant contributor to mechanical and deviation from the plan versus the outcome. And I also find number 3, just on my top list, is errors occurring along the way with how we merge 2 optical scans, or 1 optical scan and 1 a CBCT scan together. The registration of this methodology can be incredibly complex. Now, everybody at Blue Sky Bios made this look super simple, and I applaud them for that. In many ways, some of the most complex tasks are simplified through beautiful programming, just like the enable Wi-Fi button on my cell phone versus what it took to get Wi-Fi to work back in the late 90s. The sophistication of computer software is going to clearly help this. However, we still have to validate ourselves. So let's talk about each one of these. Number one, generalized human error. Guided surgery is not brain-free surgery. And a surgical guide is merely a tool in our toolbox. We know that we have to go ahead and understand that it is still surgery. Even though we're going to tell our patients it's minimally invasive, it helps with the recovery, there's going to be less, post-operative swelling, etc., potential for better outcomes, better prosthetics, it is not blind or brain-free surgery. Now, guided surgery is something that we have to understand each one of the steps along the way, because as you understand more and as your experience level goes up and your knowledge base goes up, you have better outcomes, and the literature certainly supports that. The number one thing I always encourage doctors to understand is that we have to expect error. Now, this sounds somewhat contradictory. We think, well, it's a computer, it's a print, guided surgery. It sounds perfect, right? Insane level of accuracy, micron level of accuracy. It's just something that we have to understand is that there is going to be error in everything that we do. If something is too engineeringly, or that might not be a word, but if the engineering is too perfect, it's oftentimes fault with potential error, because human beings were not perfect. And in many ways, that's a wonderful thing. But nonetheless, we have to understand that, because mistakes can and do happen. Now, this is classically the type of example of where many times a clinician wants to start with guided surgery. They say, God, I've got this patient, I do the scan, and I thought there was just a ton of bone, but it's really, really thin bone. So you know what? Let me go ahead and use a surgical guide here, because it's going to really go ahead and nail the implant. This is where doctors should start with guided surgery. Incredibly predictable places. Wide bone volumes, good bone density. Posterior mandible is a wonderful place to do guided surgery, especially in the right cases. Maxillary bicuspids, premolars are wonderful places to start with guided surgery. Implant overdentures, wonderful, amazing places to start with guided surgery. Now, that being said, I can't tell you how many times a clinician will come up to me and say, I want to use a guide here because this is a really challenging case. That is the absolute wrong way to approach. Guided surgery is wonderful for those applications, but it's not where you start. Guided surgery should be an incredibly predictable method of how we approach clinical dentistry. Second of all, we have to make sure that we understand there's a lot of potential human error for the little things. As you just saw in that last clinical example of those two patients, yeah, number 8, that's a slam dunk. Okay, yeah, patient can open up. Anesthesia is no problem. Wonderful. But on the flip side, you think, well, number 19, okay, that might be a great place to start. Absolutely. But we have to also understand that our drills have a certain amount of working space for us to work. And we look at this as a wonderful clinical example. We have this patient missing a first molar, comes to me, says, you know what, I want to do an implant here, and I want to finally have a tooth here. And I look at this ridge and I go, slam dunk. Okay, this would be a wonderful case for guided surgery. Wide keratinized tissue ridge, plenty of keratinized tissue everywhere. The patient looks like a compliant patient. Hygiene is great. Implant outcomes look nice. The bone volume looks good. It looks a little bit low density, at least according to this scan. But I can compensate for that by potentially reducing the number of drills or steps and skipping a step during the osteotomy. No problem. Let's go do it. We went ahead, and this is kind of in my early days of guided surgery. And I said, let's make an impression. Let's go ahead and do this. And then you do all these steps. You numb up the patient. You tell them what a wonderful procedure it's going to be. It's minimally invasive, the latest and greatest in technology. And then you ask the patient to open really wide. And you get this. And you look at the patient, you go, no, come on, no, just open wide for me, open as big as you can. And they look at you with their eyes wide open. They go, that's as far as I can go, doc. And we look at this entire workflow and it's thrown out of the window completely. Now I get it, doctors. There's ways to work around this, but The fundamental problem here is it's not the guide. It's not the software. It's not the print. It's not the method. It's not the technique. It's the mental software going into this. And it's not necessarily saying that, hey, Mike, I screw up. No, this is a screw up of a case, because you can see here on the right-hand side of the screen, I had to pull out the standard twist drill and approach it in a freehand fashion. And yes, we can still get optimal clinical outcomes that way, but the reality there is I just wasted several hundreds of dollars on that surgical guide. Now, maybe I can get an initial hole or a bleeding point to at least make it worth my while somewhat, but it also limited my ability to do fully guided surgery and implant placement with the actual assistance of the surgical guide. Now, this could be easily avoided with proper evaluation and examination, and I'll go ahead and go through some of my steps of what I do in my practice. What we do find, though, is across the literature shows that operator experience plays an important role in the accuracy of implant placement with surgical guides. And the reason why I show this is not to turn off the young dentists out there or the people that might be new to implant dentistry, say, you know what, I just want to do a guide because I want something to rest upon. Absolutely. I believe that. I encourage that. That is a wonderful thing of guided surgery. But keep in mind that your outcomes will consistently get better the more that you repeat or do these procedures. And it's important. The reason why I show you this is to say to yourself, you can get great stuff and wonderful clinical outcomes with guided surgery, but pick your cases. Don't choose the challenging case at first. Yes, I understand that patient might be the patient that just happens to be walking through the door. What I want you to do is to walk out of your first guided surgery experience saying, this worked amazing. And you send the pictures and you say, look at what we were able to do here. And yes, predictability and choosing the right case is many times tantamount to success in your clinical practices, because the first time that you do anything, if you get complications and problems that come up, it's going to take a much longer time to repeat and want to try that again. Second of all, let's talk about mechanical errors. Mechanical potential for error is the actual physical act of drilling of the metal-on-metal contact with the frictional components of the surgical guide, meaning how the drill contacts some sort of object, which in this case, in most cases, is the Blue Sky Bio drill with the tube, or potentially in other implant systems, drill with their tube or with their metal handle, as shown here on the top left and the bottom left. What we know is that there's also a fit of how the drill fits into the actual center tube, the inner diameter of the sleeve that fits into the surgical guide. Now you say to me, shouldn't this be perfect? If I have a 2.0 millimeter drill, shouldn't I use a 2.0 millimeter hole? Absolutely not. The tolerance can be too tight, or it can be too loose. And what we find is that there's kind of a sweet spot there depending upon the clinician. Now it varies. If anybody is tuning into this webinar from international or overseas, which I know there's quite a few overseas users and international users of Blue Sky Plant software, a lot of the other countries tend to really love a very tight tolerance of surgical guides, at least from my experience in talking with clinicians, meaning a tighter fit of the drill. Where domestically, we love a little bit of wiggle room. And I know I'm certainly that way. I love to have a little bit more wiggle room with my surgical guide, so that way I don't have any mechanical friction and I'm getting proper irrigation to the osteotomy. Then, additionally, how a surgical guide fits. And a lot of this relies upon our optical impression, CBCT scan of the patient's model, or potentially just fitting it on the CBCT by itself. Ensuring that the surgical guide fits properly is incredibly important, but then also knowing that we validate our methods, where in my case, what I love to do is when I make my Blue Sky Plan surgical guide, I also 3D print my patient's model from my optical scan or my CBCT scan of the patient's model. And the reason why I do that is you say, well, shouldn't those two be perfect? I can't tell you how many times I've done complex guides and they don't fit on my model 3D print. And then when I go to the mouth, I'm like, it's just a print, or I'm having printing error. And it fits the same way as it does on the model as it does in the mouth. I've learned over the years that I just go ahead and I fit it to the 3D printed model. Then I get improved fit. The moral of the story here is that also we have to understand how a surgical guide functions. All surgical guides basically work by this principle. You have a total drilling length from the top of something, which is your stop or your visual stop, and that is D, the distance. The implant length is something less than that distance. The difference between the implant length and the top of the drill is called offset or prolongation. And there needs to be room for tissues, depth of the tissues, sleeve room, the height of the sleeve, height of above the tissues, irrigation space, and then if you use a handle or anything on top of that. We have to be able to fit all of that in there. And some of the key things that we have to understand about the mechanical aspects of a surgical guide is that if you look at how the mechanics of just the true mechanics of the average surgical guide, you could have potentially an angulation error of up to almost 5%. Additionally, we also know that we use shorter drills and longer tubes tend to reduce the chances of error. The more contact that you have of the drill to the tube guiding you, you're going to reduce your chance of error. Additionally, using a reduction handle or spoon is going to increase the potential for error. Anything that you stack on top of a surgical guide can induce either human error, manufacturing error, or mechanical error of a surgical guide. Additionally, a longer implant, if you decide to choose a longer implant, they tend to increase the chances of deviation. As the arc of tangential basically placement of an implant, you know that if you have a longer object and a defined space, as you insert with a certain amount of pressure and angular force, there is a greater chance of deviation with a longer object. It goes without saying. There is certainly also an increased distance between the guide and the guide tube and the bone. And if that distance increases, it's very similar to implant length and drilling length, it will potentially increase your error. And then finally, we also know that greater density and irregularity of the bone increases the error. Just like on that clinical example I showed you of that number 8 or that number 19 implant, on the number 8 implant, you saw kind of an irregular bone, something that's got a spicule at the crest of the surface or something that might be a slope. Those tend to increase the potential for the guide going astray or the implant and the drilling going astray, especially on your first drill. What we know is that if you're looking at how the guided surgery functions, there's a lot of steps along the way that could go ahead and contribute to that. But I personally find, and I know that this is more empirically derived, the pilot drill really sets the tone for the entire surgical procedure. Moral of the story. Mechanical error can represent approximately 62% of the total error of the guide. Now, what does this mean? And you think, well, Mike, come on, stop it with the engineering. Let's get to the clinical techniques. I totally get it. But this is a critical slide. This is an exaggeration, yes. But if you ever want to replicate this yourself, just go print a surgical guide and try a tube and put a drill in there and look at the wobble as you insert. It is absolutely something I see clinically and something that I also see on the teaching side. What we know is that this can be a significant contributor to a surgical guide and your clinical outcomes. Now, again, this is not to scare you, but certainly simply to instill some thought and to say, okay, Mike, this makes sense. Because when I look at the totality of just one example of guided surgery, and one of the classic examples is just Nobel Guide, look at all these steps. There's a tremendous amount of complexity here, and additionally, a tremendous amount of aggregate error as the drilling cycle goes on. So even though you might only have a small amount of potential error occurring at each individual step, they exponentially will contribute to aggregate error of the implant deviation. Thirdly, registration of the STL and the CBCT. There certainly is a seemingly simple, but this is a much more complex method than it appears. Now, Blue Sky Bio and the engineers that work with Blue Sky Bio and the coders make this incredibly sophisticated. This is actually a relatively complex thing for us to do in 3D systems and CAD design because it takes a lot of triangles and triangulation for us to be able to merge these files together. And all of our optical scans or cone beam scans are made up of vertices and all these different lines and things, and I won't go into that. But what it is true is that this is a very important step for our clinical outcomes. And one thing that I do and I encourage doctors is this is one of the first things that we do is we merge an optical or a CBCT scan of the patient's dentition to the cone beam. And once that's done, I don't need to see the three-dimensional rendering like you see here on the left-hand side of the screen. And I encourage doctors, this should take more time than planning the actual guide and the implant placement. This is a critical step. And if you ever have a chance to talk to some of the industrial and professional surgical guide laboratories out there, they will tell you that this right here represents a huge portion of their protocols. This is extremely versatile, however, and Blue Sky Plan is, in my opinion, the most powerful software that exists in cone beam CT planning today because it really gives you incredible controls. And this is just a small example of where registration errors and fusion of the scans can steer you wrong. Take a look here on the left-hand side of the screen. I'll pull up my mouse thing, and I might be able to go ahead and just draw something. We'll go a laser pointer right there. So you can see this yellow outline of what we see here on the left-hand side of the screen. If you're not familiar with Blue Sky Plan, this is the outline of my stone model or my dentition model from an optical scan or from an impression of CBCT or CBCT of the model. This is showing you the outline. Now these two should line up together. The line of the soft tissue, the outline of the dentition, plus the soft tissue here, ignoring some of this here. That's just the base of the model. Now this is the same patient. All I did was rotate around to the other side. And it looks pretty close in terms of the registration of how that scan looks here. But if you look here at the opposite side, there's a significant difference in how that dentition fits here on the right-hand side of the screen. And this is something that I can't tell you enough, the importance of making sure we align these properly. This right here is a huge contributor to surgical guide errors and avoiding those problems. Now, what we know is that there's somewhere between 0.5 and 0.6 millimeters of deviation error can be attributed to the registration methods, and that's been shown in the literature. Additionally, what we can say is that any of the CBCT scans with a metal-based restoration, crown, amalgam restoration, an existing implant, you name it, a clasp. I've seen patients with scans with doctors that have scanned with interpartials and clasps and things, and that can contribute. Certainly, what we know is the photon scatter of the radiologist and the CBCT scan can add easily 1/4 of a millimeter to the above, and that's just something we see in the literature. So now once we've defined most of these potential places of where things can go astray, I'll just go ahead and spend some time and talk about what I do in my clinical practice to ensure that I take all of those things that we just talked about and I build in little things to help me improve my clinical outcomes and make it as simple and as streamlined as possible. First and foremost, comprehensive evaluation. Examining the patient and doing it in a thorough method. And now this is just a screenshot from my new patient, COE exam form. And I always want to know what the maximum opening is of all my patients. It's a part of my occlusal analysis. I'm looking at, myofascial pain, any clicking, popping, TMJ dysfunction, TMD, joint pathologies, etc. But having maximum opening is a huge, important factor, especially for some of that generalized human error that I was talking about before. And we know that a surgical guide, the drills, can be 40 millimeters plus long. Yes, they can be shorter. I get that. But yeah, if I have a patient that can only open to 25 millimeters, is that a great patient to begin with guided surgery? I've had some cases where I go, well, let's do this a surgical guide for number 18. It looks fantastic. I've got my model sitting right there on my bench top. I've got my cone beam. Yeah, let's do a surgical guide. This would be amazing. It's kind of a tricky implant position, the nerves there. And then I go in there and I take the drill and I go, shoot. That is kind of disappointing. And you go through all these steps, and it's certainly more disappointing if you spend $300+ on a surgical guide, but it's still disappointing because ultimately you're selling this to a patient or educating the patient of the outcomes and the improved outcomes, what we can do with surgical guides. Additionally, when I go ahead and I take my patients and I position them for a proper CBCT scan, it's also very important to make sure that we go ahead and we line up the patient so that way the scan of the patient's dentition is at least towards the center of the actual portion of the cone beam scan. Now, you sometimes have to tweak some of the settings on your cone beam scanner for you to be able to do this. And it is easier said than done many times. You just kind of learn from doing it a few times. If I can take my patient and line them up properly, my assistants are trained properly, we go through the mechanisms, and a lot of this is covered on my online course, but nonetheless, this just comes with experience. You also make sure that your assistants don't think of doing this as like a panoramic radiograph, because panoramic radiographs are clearly different from CBCT. It goes without saying that we're trying to also avoid patient movement and minimizing background noise and scatter. And you say to yourself, oh, yeah, Mike, it totally makes sense. But also I showed you this example. Now in my office, I have a stand-up cone beam. I've also worked plenty with sit-down cone beam machines like iCat or Prexion Hitachi units. And what I found is that in my clinical practice, I treat a predominantly older population, and my older patients have a really tough time standing in one of these machines. And even though my machine, says, okay, you can go down all the way and you can scan a patient sitting down, easier said than done. CBCT scanning is important to ensure that if we get our patients to remain as steady and as stable as possible, having movement to my CBCT scan can dramatically alter the clinical outcome of my guided surgery. Certainly minimizing background noise and scatter. We have to be careful there because there's a lot of metal reduction modes present on a lot of dental CBCT, and that type of beam hardening that can come associated with it can also cause changes in how the thresholding or the slider controls in Blue Sky Plane interprets the bone or the dentition. So be careful there. Now, it's easier said than done to reduce that. Certainly some of the newer CBCTs have very intelligent algorithms to be able to go ahead and minimize that. Also, voxel size and exposure time. Now, this might be called in your CBCT the resolution, high resolution versus low resolution versus medium resolution. What I generally recommend is do a CBCT scan, funny enough, at a medium or low resolution. And you think, oh, Mike, I should do everything at high resolution, shouldn't I? Well, the important thing to understand there is that high resolution scans not only expose our patients to more radiation, but they take longer to expose, potentially inducing artifacts and movement blur, like you see here on the left-hand side of the screen. Not only do we have artifact error with all these starry night appearances, but we've got double imaging, ghosting imaging. So even though the pano might look good, this particular patient was an older patient, could not stand still for that exposure time required for a 0.3 millimeter voxel size, or a 0.4 millimeter voxel size was a significantly faster scan. One thing that we don't necessarily talk about that much, but it's something that I genuinely believe in, is soft tissue separation and occlusal separation of our CBCT scans. I basically advocate for never having your patients bite down together with their dentition on a CBCT scan. Now, this is true of single, double, and full arch surgical guides where you're not going to be building the dentition. So asterisk, 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 if you're doing some of the innovative guided surgery techniques like, similar to the end sequence system or what Corey is showing or what Nate is showing with their techniques where they build the dentition, we know that those types of procedures, you need to have the patient at their proper vertical. But those are also cases that, frankly, not a lot of clinicians genuinely have the interest in doing. And there's nothing a slight against either of those two fine clinicians. But what I find is that most clinicians, when they use guided surgery, want it for their kind of onesies, twosies, and their regular kind of routine cases. And yes, we do want to go ahead and use it for our full arch guides. The complexity of going through those procedures is magnified. However, with that being said, there is a wonderful application for both of those systems. So I'll check out their webinars associated with that. When I look at my scans, if I can think of a generalized protocol, I always want to have the patient separate their occlusion. And then additionally, I use cotton rolls to separate their teeth from their mucosa or soft tissues. And we take a look at that because these are two scans showing you a fairly similar area. We have a patient missing a number 8, and this one just happens to be a number 9, but a central incisor. You can see here, this is the typical example of what a CBCT scan here looks like. You can see here, I've got some shadowing, some gray. All of this right in here is the lips, tongue, nasal cavity. All of that gray area is soft tissue, and we know that this is the bone and the dentition. We can see it clearly. If I go ahead and look at that, I can't really see what the soft tissue is showing me here. I don't see what the alveolar ridges, the thickness of the mucosa, and digitizing and joining digital scans, optical scans, or CBCT scan of a patient's model or impression is more challenging in these cases. In my clinical practice, this is the type of demonstration of what I like to see. Very clean CBCT scans. I can see the occlusal dentition of the patient all the way around. Then, additionally, I have soft tissue separation of the palate plus the lips, and I can clearly see the gingival outline. And I call that an ideal scan because I'm going to show you the things that we can do with that. How I accomplish this effectively and efficiently in my clinical practice is this. I CBCT scan a lot of my patients wearing some sort of automatic cheek retractors, plastic cheek retractors, or simply just cotton rolls. The Optrogate system, wonderful system. You can pop this in your patient's mouth and then go ahead and do your CBCT scan with 2 cotton rolls. Very fast, very efficient. Additionally, what I'm also doing, just to step back, I have my patient with their tongue away from both their palate and their mandible. So it's kind of hovering right in the middle. If I get a little bit of movement, soft tissue artifacts from the tongue, no big deal. What we also want to do is we want to work with some sort of optical scan. Now, what we find is that there's wonderful ways of doing that, whether it's based upon an optical scan at the desktop level or the laboratory level, or direct imaging within the mouth. What we can also do is CBCT scan our models or CBCT scan our impressions with a wonderful technique from a colleague of mine, Dr. Rick Ferguson, a wonderful technique. Generally, in my practice, I prefer to do direct imaging within the dentition. Direct imaging is fast, efficient, and incredibly accurate for generating optical scans of my patient's dentitions. It also fits in effortlessly with my clinical workflow. I have 2 scanners in my practice, one true definition and then one trio scanner, and I use them for different applications. You're welcome certainly to talk with me about that on a separate level. However, optical scanning, whether you do it with a CBCT, a model-based scanner in the laboratory, or optical scanning inside the mouth, you can get very nice results. What we can do is whatever method you choose, we're going to go ahead and register and pick off the pinpoint positions that many of you I know are very familiar with doing. But we're going to join these 2 scans together. And when I join those 2 scans together, like in this video shown just from my online course, you can see here that we can go ahead and pinpoint different positions of us being able to find key points for us to go ahead and initially join these scans. And we also have to understand, though, is that this is just one method for us to join the scan. And this particular method that's available through the Blue Sky Plan software is incredible. It results in wonderful registration methods. And as you see here, as I show here on my slider as I move across, results in a yellow outline fitting just effortlessly around that soft tissue separated patient scan. Dentition is separated. I have very clean dentinal surfaces, a dentition. Plus, I cannot emphasize enough the value of being able to see that yellow line around tori, palates, other portions of the soft tissue in multiple dimensions. And then additionally, when we start to look at some of these things, we know that we can further join these scans in other methods. And we know that if we take a look at that, that's just one method for us to join the scan together. And many times I have to go ahead and switch my methods. And the 2 methods I like to use is just that initial method of joining together the panoramic and the optical scan, but then also using the point cloud method. So I really almost genuinely prefer this method. I really like the automation of the other method. However, if something is just a little bit goofy, or if I have a patient with a lot of metal artifacts, I'll use individual pinpoints on cuspal forms, lingual cusps. And what you'll notice here is I use very discrete portions of what's visible on the CBCT. And look at how clean that CBCT is too, is when we use soft tissue separation, cotton rolls, Optrogates, everything of that nature. It's very easy for us to go ahead and find those exact points. And all you saw was a very slight movement of my optical scan of how it moved as between the two different types of scans. And as we do that, we still want to verify and look at all of the merging of these two files of how they come together. Then, as we start to approach our full arch guides, we know that if we look at this, this is the typical example of what we would see for the fully edentulous patient. And the doctors out there and people tuned in that know me know that I kind of do a pathological level of implant overdentures. And what I found over the years is this approach of just doing a scan and not having a restorative plan here is somewhat problematic. You can do the exact same soft tissue separation techniques with a denture. If you just use cotton rolls and an Optrogate or just cotton rolls by themselves, I can CBCT scan the patient wearing the denture by itself. And by doing that, I can see the intimate, beautiful outline all the way around the dentition of the denture itself. And now, why didn't you see it in the last scan? That last scan I showed you, the patient was also wearing the denture in that scan. It's because the radio density of acrylic resin is similar to that of soft tissue, so they all blend together. But if I create an air pocket, you can easily see cuspal forms. And then if I massage and change the slider dynamics, I can even see a rendering of a patient's denture. Clear as day, without any special barium, foil, any sort of technique of needing to use fiduciary markers or alignment pins or spherical markers. And when you take a look at that, this particular approach allows us to leverage this technology and be able to do it in a very creative way. By being able to do that, I can then take these full arch guides and being able to join these scans together just simply with basic rudimentary outline forms and soft tissue separation. And this is a technique that I've been working on and something that I helped bring to implant dentistry of using a radio opaque impression material. And doing that, you can also go ahead and do that in a variety of different methods. Originally, you can use a desktop scanner or pour a model from that, but you can also just strictly use the CBCT scan of the patient's denture alone. So my general protocol is this. I'll take this radio opaque PVS, reline the patient's denture, do the CBCT scan of the patient wearing that denture plus the radio opaque PVS. Then I'll go ahead and CBCT scan the radio opaque PVS by itself. Then go ahead and use Rick Ferguson's technique of inverting the impression, all done by a CBCT method. Additionally, if you want to, it's up to your clinical judgment, but you can also combine that with a stone model. But doing that, I can also leverage those soft tissue separation techniques and challenge myself with these simple cases, which is an implant overdenture case. By doing that, it's sophisticated, works very easily, and then also ensures that your surgical guide is going to fit properly. Then you can step it up to the next level, which is go to more the full arch style surgical guides, sleeves, tubes, and then start printing your own and fitting your metal sleeves. And by doing that, I can leverage this technology and make it easier, faster, and potentially more accurate. But the ultimate goal is we want to go ahead and improve our patient outcomes and certainly improve our patient experiences because it's all about the patients here. Improving our outcomes, improving our patient experiences so many times that the patient just leaves this procedure or even just a consultation and says, wow, they totally get it. And now, yes, I'm not going to go into the nuances of all this stuff with a patient, but I guarantee you that every scan I do of a patient, I sit down with them and I plan their case right there in Blue Sky Plan software. And it's very impressive for the patients. And they walk away going, wow, this person really knows what they're talking about. So just kind of some final slides just to finish it up. What's also important is for us to go ahead and talk about how we improve our clinical steps and techniques and avoiding the rookie mistakes for a variety of different guides. Now, we have three different main surgical guide options. You have the fully guided surgical guides, which is full template assistance, and all the procedures are completed through the guide. Additionally, you have template assisted full osteotomy preparation, aka partially guided, meaning you complete most of the procedures, but not the implant placement through the surgical guide. So things like drills, bone taps, bone reduction, et cetera, et cetera. And then you have the kind of basic guide, the pilot guide or the template assisted pilot drill preparation, where only one drill, whether it's a lance spur or a 2.0 pilot or a 2.3 pilot drill is used for these surgical guides. And I showed this slide earlier. Because many of us look at, hey, I want to do surgical guides because I want to do everything through the surgical guide. Absolutely. That's a wonderful way of doing implant dentistry. However, it's not a bad idea to kind of reel that down a little bit and not start there from day one. Because this is a very complex step, which could induce a lot of mechanical errors. Like I said, there's a significant portion of that in implant dentistry. And I know I've done so many surgical guides and so many surgical implant placements using fully guided surgery. And you see little things along the way that you say, God, why did that happen? Where we can also go ahead and go is the partially guided surgery or template-assisted full osteotomy preparation, which is manual surgical access, and then all of your drills are done guided, followed by manual insertion of your implant with or without a flap. This is a truly wonderful way of doing guided surgery, and it really, really is a great way for a lot of doctors to go ahead and say, you know what, I want the benefits of guided surgery, but you know what, I want to kind of stop short and say, let me just make sure that that bone is there. They might do a small little tiny envelope flap just to take a look at the bone just before the implant goes in. And then finally, the basic surgical guide, which is the pilot preparation guide only. And this is one type of guide that I absolutely love doing. And the reason for that is that the vast majority of the techniques is done freehand or without the assistance of a surgical guide. However, in my personal opinion, empirical driven, this is not research evidence based, I estimate that approximately 80 to 85% of my implant position is controlled by that first drill. And if I can go ahead and say, you know what, I'm going to use a surgical guide to give me that first drill and then complete the rest of my drills just with full control, I'm going to potentially reduce some of those mechanical errors that compound throughout the cycle of what you just saw. And this can be accomplished by one of two methods. The method that I really love is to use the Blue Sky Bio Drill NSS or Drill NSL plus Tube 22. And this is something that I teach a lot of doctors in my courses because it's a very nice way to get started with guided surgery. And once you understand the core fundamentals of how you size the tube, how you size everything, the length controls, offset, prolongation, tolerances, and everything, stepping up to the fully guided surgery is a piece of cake. And this can be also accomplished if you have an implant system that you utilize, such as BioHorizons or 3i Zimmer Biomet, et cetera, et cetera. Most of them also do have their own pilot sleeves and pilot drills. However, I think the Blue Sky Bio tubes and drills are the best. So to kind of sum it up, I really advocate the number one thing is to learn from and work with a mentor. And I had a wonderful discussion about this with Rick Ferguson the other day. We met up at MIT in Boston, and I got to tell you, I think this guy is fantastic. What he does in his courses is he teaches the basics of implant surgery, and then he sends the doctor home, and their first surgery they do by themselves is with the assistance of a surgical guide. And I thought that was genius because it basically gives the doctor that kind of, there's somebody right there with me. Dr. Ferguson is right there holding my hand as well while I'm doing this procedure. I thought that was amazing. So I encourage you to check out his Continuum, really wonderful resource. But nonetheless, the first time that you really do anything, whether it's having a in-person live mentor or a virtual mentor like you see in the Blue Sky Bio Academy and Facebook group, we can really learn from each other. And don't be shy. Post your good stuff and your bad stuff. We learn from both, and many times we learn more from our error than anything else at all. So, in my opinion, I recommend first learn some of the basics of freehand surgery, meaning go attend a course, learn some of the mechanics of it, try it out, do an implant or two with somebody there, over the shoulder type exercise, and then go to surgical guides. So, meaning like in Dr. Ferguson's example, he sends you home surgical guide, your first case. That's a wonderful way of doing it. And in many times also, if you're going to kind of look at the complexity of guides, if you're going to go do it on your own, you don't have somebody like Rick working with you, I recommend really starting at the basic level. It's then partially guided, then finally fully guided. And like I said before, really learn from our mistakes, pick our brains, work with us. And what happens there is that when you really look at the root of it, keep everything simple. And one thing that is just amazingly simple is the guided surgery kit from Blue Sky Bio. It's just incredibly sophisticated, but simple in its finest virtue. And simplicity is our goal with almost everything that we do in dentistry. Simplicity leads to predictability. And a part of this as well is that as we learn from each other, and we tend to have online mentors and virtual mentors, I certainly encourage you to check out my online course as well as my in-person courses. We've been running it for several years now, and sell out every session. The doctors who walk away from these courses say, oh my God, this is incredible. And not everybody's going to want to do guided surgery. You say, well, even if I don't want to do it, I want to attend a course like this just to say, how is this done? And it makes me a better clinician knowing that. And check out the webinar. The coupon code is BSB webinar. It's $100 off for that course. And the power of this too is being able to work with each other, with a team, to be able to collaborate, and most importantly, have fun. Because let's be frank, if you're not having fun, we're not doing dentistry. If you're not doing dentistry, you're not having fun. This should be fun. It should be exciting. And in many times, even if you're sitting there going, you know what, I'm kind of bored of just doing the same thing all over and over again, there is nothing more fun in implant dentistry and in clinical dentistry than doing your own surgical guides, 3D printing, and the power of collaborating with each other. So we're just going to kind of wrap it up here, and I thank everybody for their kind attention. This is my email address listed right here, and what I'll do at this point is we'll go ahead and open up to the floor for any questions that the audience members might have, but I'll pass it on off to Michael Saltzman from Blue Sky Bio to kind of take it from there. Thank you.
Great. Thank you so much. That was amazing. If there are questions, you can enter them into the chat box, and we'll pose them to Dr. Scherer. Also, please make sure to complete that webinar attendance form so we can send you that CE credit.
Well, looks like we got it all.
So getting a lot of compliments, and thank you very much for the great presentation, for the great webinar. A lot of very positive feedback coming in.
Perfect. Like I said, Michael, I lend to your experience as well as somebody who's a visionary for developing software and systems. Just in my learning process over, the past 10 years of just kind of hacking and having fun and a lot of mistakes. I mean, I got to tell you, it's just amazing how all of this is put together, and it's so sophisticated, but yet at the root of it is just very, very simple. Once we all understand kind of the basics of the length and the size and whatnot, it really is a lot of fun. So I certainly encourage everybody to check it out.
Well, I think one of the things that makes Blue Sky Plan really amazing is what you were discussing earlier, is really the community of doctors that are involved with it, giving feedback, giving advice and suggestions. And not only that, the community that's willing to give from their time and answer questions and give suggestions to other doctors that are starting with the software, starting with guided surgery. And I think a combination of all of those things together really drives the success of the software and the doctors using the software and the treatment they're giving their patients. Okay, we actually have a bunch of questions coming in now. Let me scroll through a couple of them, and we'll see if you can address them. Okay, you touched on this, but somebody's asking again if you could discuss what the best technique for superimposition of the ones available, which one would you recommend?
Just like I mentioned in the presentation, and that's a very good question. So they're asking, okay, we have a laundry list of different choices of how we could merge an STL with a DICOM data set or a cone beam. And frankly, I absolutely love when I click import to the STL. It brings up kind of the panoramic registration where I can just click the center of the teeth. That really nails it probably 9 times out of 10. And I've worked with a lot of software out there, and Blue Sky Plan, to my knowledge, I think is the only one that truly has a powerful feature like that. Like I said, it's a start. So I click it, and I click the center of the orbs, the initial pickup scan. You click the center of the teeth, and then on the model, and then I click OK. It aligns it, and then I'll go through each individual slice and then make sure that my little yellow or green or whatever color line has popped up is wrapped around the teeth. And if I see any sort of deviation, which, like I said, 9 times out of 10, generally not, I'll go ahead and then use the actual points module. So you have the under the model tab, you can go ahead and align to point. So I'll click on the points little stereo button, and then click on, or the circle button, and then click on align. And then when I do that, it pulls up a 3D rendering of the patient, and it also pulls up a 3D rendering of the STL file. And part of the reason why I find that the initial one, the panoramic mode, might not pick up the registration is because there's metal restorations or scattering effects. And when I can go ahead and see like the distal lingual cusp of a tooth and the incisal edge of a central incisor, or picking up even bony contours, if those translate through, the point cloud really will pick up the high level of detail. So I wouldn't go as far as to say I would use the point feature registration for every case automatically. However, it clearly is kind of my fallback plan.
Okay. Do you experience the implants walking after you use a pilot guided drill? And if so, how do you deal with that?
Absolutely. So what happens there is that after a pilot guide drill, you still have a 20% chance of in my opinion, of deviation of the final expected outcome versus the virtual outcome. However, let's kind of really look at that. When you look at the prosthetic nature of what we're trying to do, we're trying to get the angulation and the bodily position of the implant within the bone volume. The pilot drill really gets that. Once you go ahead and use the pilot drill, when you go to your sequential drills, and this differs depending upon which implant system you're utilizing. So case in point, if you use something like the Nobel Replace or the taper drills from, say, Nobel or 3i Navigator, those systems have a cylindrical drill followed by a quad or a tapering style drill. Almost looks like paddles. There can be a significant, in my opinion, deviation of those types of drills if you're just using pilot guide only. Contrary to that of the Blue Sky Bio drills, or potentially like something like the Bio Horizon drills, which use a quasi or cylindrical drilling protocol. So that the first drill is cylindrical, true cylindrical in shape. The Blue Sky Bio drills are progressively cylindrical, but you've got kind of a narrower tip to it. So that way it grabs that center part and then goes. Alternatively, drills like the Bio Horizons drills, they actually kind of almost like feed into the osteotomy. So they're almost self-guiding, and that's really powerful. So one thing also that I do whenever I do any sort of a guided implant surgery is I don't necessarily believe that we should be drilling while the drill goes into the surgical guided sleeve tube. I like to go ahead and rest the tip of the drill in the initial osteotomy and then activate the drill to kind of let it walk down.
Okay, let's take one more question and then I think we'll wrap things up. How do you feel about the accuracy of CBCT scan of a surface versus a model scan or an intraoral scan?
Well, we're finding that CBCT scanning of models is actually quite impressive of how accurate it can be and the fidelity of the optical image output from the model. And, I'm the type of person, I typically like to go ahead and minimize any potential areas of error. And there is a moderate chance of error that occurs between a traditional impression and then when you get to the optical scan of the stone model or the PBS impression. Generally, in my preference, in my clinical practice, I really use a tremendous amount of intraoral optical scanning just because it's something I use in my crown and bridge workflow. And I just genuinely 100% believe that intraoral optical scanning is rapidly approaching proliferation and should be in every dental office. I would stop short of making any additional statements after that. However, intraoral optical scanning is probably one of the best things I've done for my clinical practice in some time. In addition to that, model-based scanning of CBCT scanning of models clearly works, and also using a laboratory scanner of a stone model works because certainly I understand that optical scanning, intraoral optical scanning can be cost prohibitive to many clinicians. CBCT scanning is an avenue for being able to accomplish that, and especially for some of my oral surgeon, periodontist friends that might not want to start on the intraoral scanning route. So whenever possible, just to answer that question succinctly, I always like to choose a step that will help to minimize any potential extra steps.
Okay, and just to address some technical questions that are coming in, this presentation will be available via YouTube. It's being recorded and will be live on YouTube shortly after the presentation. It will also be available via the Blue Sky Bio website as well. And again, regarding the CE credits, there's a link in the chat box to the form. I'll post it again. So please go into the link, enter your relevant information, and we'll send you the CE credits via email. Dr. Scherer's contact information is currently on the screen. If you have questions for Blue Sky Bio or particularly regarding the software, you can email us at plan@blueskybio.com. Dr. Scherer, I'd like to thank you very much for taking the time, putting together the presentation, presenting the presentation, and sharing your tremendous wealth of information with everybody out there.
Thank you, Michael. It's an honor and a privilege to be able to do this for everybody. And thank you for everything that you do in the Blue Sky Bio community.
Thank you very much. And thank you for everybody who's attending the presentation.